So the first type of organic compound that we'll take a look at in more detail is an alkane. So hydrocarbons are organic compounds that contain only carbon atoms and hydrogen atoms, and alkanes are an example of a hydrocarbon. So alkanes are the simplest hydrocarbon, and they only contain single covalent bonds between the carbon atoms. And alkynes are known as being saturated hydrocarbons because there's only those single bonds between the carbon atoms. So a saturated hydrocarbon is a compound of carbon and hydrogen whose molecules only contain carbon-carbon single bonds. And we'll take a look at some other examples where there are double bonds and triple bonds present in a future slide. So example of alkanes, methane. This is the simplest alkane. It just has one carbon. Ethane has two carbons. Propane, 3 carbons, and butane has 4 carbons. So these are some common alkanes and the simplest that we can represent. Now, when we name something in organic chemistry, what we'll end up using is we'll use the IUPAC, or International Union of Pure and Applied Chemistry system. So every name in an organic compound is going to have 3 parts, and there's going to be a prefix, root, and a suffix. So the prefix, that gives the position and names of any side groups or branches coming off that main chain. The root, that's going to indicate the number of carbons in the longest continuous chain. And the suffix, that's going to indicate the functional group to which the molecule belongs, such as an alkane. So the functional group, that's a characteristic arrangement of atoms or bonds within a molecule that determines the most important chemical and physical properties of a class of compounds. And it's the type of group to which an organic molecule belongs. So going on and figuring out how we exactly name these things, this slide is quite complex, but we'll go through some examples in the future. So we said that every name is going to contain 3 parts. So alkanes, they're named using the following steps. The first thing that we're going to do is we're going to identify the root, and that's also called the parent chain. And the root is going to be the longest continuous chain of carbon atoms in the molecule, and you need to be able to memorize the names of all the roots. You have to know from 1 to 9. And we see that in this chart right here. So if a organic alkane has just 1 carbon, it has the meth root, 2 eth, 3 prop, 4 but, and so on. So this chart, very important to memorize and know what all the various ones are. Then we identify the suffix, and for alkanes, they only contain those single bonds between the carbon atoms, and they'll have the suffix -ane. Then we identify the prefix, and the prefix indicates the location of any kind of side groups that are coming off of that main parent chain or main root. So if the side group of hydrocarbons is a hydrocarbon, we'll add YL or il to the ending. And for example, if we had a 1 carbon side chain, then it would be meth-ol. That side group just gets that ol. It's a denotation at the end for the end. So the position where that side chain or group is located, we need to indicate that by numbering the root or the parent chain. And what we want to do is number the carbons so that the side chains have the lowest number combination possible. The side groups are then listed alphabetically, and if there's more than one side group that is the same, we start to use the prefixes di for 2, tri for 3, tetra for 4. And these prefixes, we don't count them when determining alphabetical order. And if there's any, to separate the numbers and the letters, we use dashes, and we use commas in between any numbers. So this slide, very, very complicated. There's a lot of information, but let's go through some examples so we understand exactly how to apply these rules. And we'll take a look at some common mistakes as well. So the first thing that we're going to do is we're going to try to name this alkane right here. And we're going to use those steps that we just learned about. So the first thing that we need to do is we need to identify the root by looking at the parent chain. Remember, the parent chain is the longest continuous number of carbons. So in this molecule right here, we have all these carbons. They're making a continuous chain. And we see that we have 1, 2, 3, 4, 5 carbons. So then we're going to have to use our table that we've memorized and remember that if we have 5 carbons, that has the root name of pent. So we're going to write that down. The next thing that we're going to take a look at is the suffix. So the suffix indicates what family or what group of this organic compound belongs to. I've already told you it's an alkane, but we see that we have carbons and they're just bonded by single covalent bonds, so we know that we are dealing with an alkane. So we add ane to the end. So this is just pent-ane. Now that one is easy because we didn't have any side chains off this one. It was just a continuous chain of carbons. Let's take a look at an example where we have some side chains involved. Let's take a look at a little bit more complicated example. In this example here, we see that we have a side chain present. So the first step again is to identify what the root is. So we're looking for the longest continuous chain of carbons, and we see that's right here, 1, 2, 3, 4, 5, 6, 7. Then we remember what our root names are, and if we have 7 carbons, we have the root name of hept, and we'll write that down. The next thing we need to do is identify what the suffix is, and the suffix in this case we're dealing with an alkane, so this becomes heptane. The next thing we need to do is identify the prefixes. And the prefixes are indicated by those side chains here. So we have a side chain here, and it's a 1-carbon side chain. If we have a 1-carbon side chain, that means we have a methyl group. We add YL to the ending. So now we have methyl heptane. What we need to do, though, is we need to identify where that side chain is on the parent chain. So what we'll do is we're going to number our parent chain so that the side chain has the lowest number possible. So I'm going to start my numbering over here. 1, 2, 3, so that the side chain has that lowest number. It's attached to carbon number 3. So I'll write it down as 3-methyl heptane. Now what we do is we use this little dash that go between numbers and letters, and if we had multiple side chains, we'd have multiple numbers out front, some potentially, and we would use a comma between those. And we'll look at that in the future. So common mistakes when we're naming organic compounds. We know that this is the correct name. It's 3-methyl heptane. Let's see what would happen if we named the wrong root. Instead of having the parent chain as this long continuous chain of carbons, instead if we went up and over here, how many carbons would we have? We'd have 1, 2, 3, 4, 5, 6, so we'd have hexane. And our carbon, or our side group, sorry, would be attached to carbon 2. And there's 2 carbons in this side group, so it would have a prefix of ethyl, and it's on carbon 2, so we would think this was 2-ethylhexane. And this is not correct because we want the parent chain to have the longest number of carbons possible. The other thing that we can make a mistake on is incorrect numbering. So we said that we wanted to have this side group to have the lowest possible number. If we numbered from this direction over here, this would make this carbon number 5, giving us an answer of 5-methylheptane. That's not correct again because we want that side group to have the lowest number possible. Let's take a look at another example. This one is a little bit more complicated yet. So what we're looking to do is name the alkane shown right here, and we're going to start with the same steps. The first thing that we're going to do is we're going to identify what the root is. Remember, the root is the longest continuous chain of carbons. And if we take a look at this molecule right here, we see that this is the longest continuous chain of carbons. We have 1, 2, 3, 4, 5, 6, 7, 8. Note that I could have also continued numbering this way and went 1, 2, 3, 4, 5, 6, 7, 8. You would get the same answer. The big thing that you need to remember is that you want to have the longest continuous chain possible. And how you do that, it doesn't really matter, just as long as it's as long as possible. So we've got an 8-carbon chain. So if we take a look at what the 8 root name is, it's oct. So we're going to write that down. And since we're dealing with single carbon bonds, what we have is the suffix of ane, octane. The next thing we need to do is identify the prefixes. And in this case, it's a little bit more complicated because we now have 2 side chains. We have a methyl side chain right here, or a methyl group, because we have a 1-carbon side chain, so methyl, and then we have a 2-carbon chain, and that's going to be ethyl. So what we need to do is we're going to list those alphabetically. So this becomes ethyl, methyl, octane. So remembering the E becomes before M, that's why we've listed in this order. Then we need to number the side chain, or sorry, number the parent chain so that the prefixes have the lowest numbers possible. So I'm going to start numbering over here because that makes this side group right here onto carbon 2, and that makes this side group right here on carbon 6. So we have a 2, 6 number. So we got 6 ethyl, 2 methyl, 6 because that is where that one's coming, and 2 because that's where that one's coming. Remember, it's the alphabetical nature of the side chain that is dictating where they are and what order they're listed in, not their position on the chain. We just have to make sure that these numbers are as low as possible. Had I started numbering over here for my parent chain, that would make this 3 and 7, or 7 ethyl, 3 methyl octane, and that's not what I want to do. We want to have those lowest numbers possible.